Hi, one of the viewers from this channel want me to do a reverse engineering of this motorcycle valve cover. He wants to do a 3D print version of this valve cover with a nylon SLS. I never seen a motorcycle using a plastic valve cover before. There are 3 mounting holes for the M10 screws, and on the inside it has an O-ring groove. And the shell has to be strong enough to distribute the even force to place the O-ring against the mounting face so that the oil won't be leaking. So the shell cover needs to have a good stiffness so that it won't flex when the 3 bolts are mounted onto it. Okay, let's take a look how he scanned it. So the viewer used a RevoPoint Mini 2 for scanning this part, and he bought it 1 week earlier and learned it. So he scanned it with a 0.1mm resolution, and he was using a reverse scan 5.5.4, and there was a bit of a complaint that the markers were not deleted. Okay, let's take a look at the specification of the scanner. Okay, so the viewer never told me why he chose to use the Mini 2 for making this 3D scan. And from RevoPoint website, it costs at $663 US. And if you look at the single frame precision, it's 20 microns. So it's very high precision 3D scanner, one of the highest that I have seen from this specification. Okay, let's roll down a bit. See, this guy is making a 3D scan of a gearbox, which is very similar to the valve cover. So anyone who run into this advertisement will possibly believe that this 3D scanner device is capable of doing a 3D scan and reverse high precision automotive part with a very low price. See here, they still say up to 20 microns, working distance 25 cm maximum, and single capture range 9-axis IMU, again 0.02mm. So here's another pictures that this guy is making a 3D scan of a gearbox, a very large gearbox, much larger than this valve cover. So it has an RGB camera, a 9-axis IMU, low latency, okay, Wi-Fi 6. So they have a lot of model scans, which just look very promising. Turbine, gearbox, okay. Okay, let's take a look at the specification. Single frame is 20 microns. That's the precision, right? Accuracy is 50 microns, and point distance is also 20 microns. That's very dense point distance. A depth camera is only 2 megapixels. Let's take a look at the 3D scan result from this Mini 2. He made 2 scans, the outer shell here and the inner shell, and then merged together. First thing I noticed is that there's a double wall here. This is something that you need to check before you start to do the reverse engineering. Maybe some of your customers send you the 3D scan files. You need to inspect the quality of the scan before you can start. Because this is an automotive part, the machining cost for this part is very expensive, so it has to be very precise. Double walls is the sign of the low precision scan. It means that the first scan that he made on the outer shell doesn't have the same dimension as the second scan that he made from the inner shell. So when he scanned the inner shell, this wall, the overlap wall, has different dimensions. So when they merge it, some part of the wall is merged seamlessly, but the front part of the wall is not. And if you look at the variation value between the 2 scans, delta Y value is 0.5mm, that's 500 microns, which is too much for automotive part, especially the metal part. For the plastic part, I would allow at least 0.1mm, 100 microns over, because you can compress fit a plastic part is flexed, but for the metal part, anything above 0.1 for engine part is absolutely not usable. And same as the viewer state before, the software, the reverse scan software, is trying to fill the hole from the marker, but for some reason it doesn't do a good job filling hole, but it's everywhere here and there. To be able to successfully reverse this part, you need a complete scan outside and inside combined seamlessly, because we need to check for thickness when you cut into the cross section. Okay, let me show you. Because when you cut into the cross section, you need to be sure that the thickness is correct. Okay, so here we have a double wall. See, we have double wall inside. See this? They have 3 walls instead of 2. So this information can confuse the designer, person who do the reverse. See, there's the wall, the double walls go up from here. I don't know why there's a 3 layer of the wall on this side. So if I measure, I have already used a 3-point alignment. So I'm going to measure this point and this point variation. So see, delta C, look at delta C, it's 0.126, that 126 microns different. Okay, let's try from this side to this side. Okay, from this side to this side, delta C is different, it's 134 microns. So that's quite a lot for mounting flank of the valve cover. It's too much. 0.1 is way too much. Let me check one more point. This point to this point, same, about 0.1 millimeter variation. Okay, this is the outer shell of the valve cover. The part is symmetry, so nobody is going to make this part asymmetry. From what you can see with your eyes, it's a good clean scan. It should be satisfied with a 3D scanner, right? But until you start to measure a discrepancy between the left side and the right side dimension, let me show you. If I measure the left side here from this point to this point, and then I measure the opposite side on the right side. If you zoom in, I try to get a clean point where it's flat, there's no extension. And if you read the value, see 70.78 millimeter on the left, but on the right is 68.62. So the discrepancy between the left and right measurement is 2.155 millimeters, which is very high error value. Okay, let's take a look at another pair. So we have this pair, measure from this point, the flat part, to the flat part here, and another point from this flat part to the flat part here. Okay, the measurement is aligned with the first measurement. One side read 62.737, on the right side read 60.611. So the discrepancy is 2.023 millimeter, that's 2000 microns. So it's 100 times less precise than what they claim on the advertise. And for this scan, I would say it's not suitable for reverse engineering. So I have already informed the viewer that he needs to make a new scan. You can spend less money on a cheaper scanner, but you're not going to get any usable result from it. So you spend $663 for a 3D scanner that look promising, but the end result, it's 2 millimeters of the error from the left side and the right side, and 0.1 millimeter just for the flat mounting flank. So it's I know for most people you want to spend less money on the 3D scanner because you not frequently use it, and when you look from the specification, it's cheaper, it's better, but in reality when you put it into the real job, it will give you a very high error, and you won't be able to use this scan for reverse engineering. So if I use this scan, I'm going to draw just one half and mirror it to the other side because it's symmetry, but on the left and on the right has 2 millimeter discrepancy. So this 3D scanner is not a micron level. If you use a ruler, a metal ruler for measuring this part, it's going to give you more accurate value than this one. So be careful when you choose or invest in the 3D scanner. This 3D scanner is breaking reverse engineering industry. A lot of people believe and trust the advertisement, but in fact, it's not giving the result that they promise. Before you continue to do a reverse engineering, you need to do a several check. If the part is symmetry, it's quite easy to check. Check the dimension on left side and the right side, up and down, to see if it reads the same value. With the machining part, it should be less than 60-70 microns different. But for the casting part, injection mold aluminum, it should be less than 0.1 millimeter. So if you don't check, you just look at the scan, you're probably satisfied with the result, right? I get the scan, I merged it, but you can't use it for anything except for spinning around in your monitor, render it and post it on social media. That's all you can do with this scan. Alright, I hope that this information is useful. What you need to check before you start reverse engineering. What's the 3D scanner precision has impact on the reverse engineering. So if I reverse this part, the left side and the right side is not going to match. Okay, that's your guide for watching. I'll see you in the next video.